we are going to introduce a new type of notation called interval notation. Okay, and it replaces inequalities. So notice that inequalities means that something's not necessarily equal to. So way back in elementary school, you learned that this is a less than symbol. You learned that this is a greater than symbol. You learned that this is less than or equal to. And you learn that this is greater than or equal to. Okay, and when we graphed these things on a number line, you would use an open circle for this one and for this one. And I'm going to explain that in a second. And you would use a closed circle for this one and for this one. So let's just do a quick review on inequalities, and then we're going to morph it into interval notation. So I'm looking for all my cool pencils. Why don't I have a green one? Oh, I do. Okay, so what we have then is inequalities. So if I have this, and I'm just going to make stuff up, x is less than 3. So the issue with math is that sometimes it's easier to say what something is or is not than it is to be explicit, meaning if I list all the numbers less than 3, I'm going to be listing for a long time. So if I just say every number that is less than 3 works, then that means there's an infinite number of answers. Okay, there's an infinite number of answers for any number less than 3. But it can't equal 3. Okay, because 3 is not less than 3. That doesn't make sense. So your value cannot equal 3. Now do not get into the pit of despair and figure out and just say, well, okay, so it's everything from 2 smaller. Well, what about 2 1/2? Okay, what about 2 1/4? What about 2 15/16? Okay, so I can get infinitely close to 3. I could say that my answer is 2.99999, go on for an infinite number of 9s, and end with a 9. Okay, so that basically it's 2.9 forever. Okay, that's not 3. That's a valid answer. So what we did when we graphed it on a number line is we would make a little number line, and you would have to tell me what number you're interested in. Well, I'm interested in the number 3. I am interested in the number 3. So what values are part of my answer? My answer is everything that is less than 3. So if you need a little visual clue, that looks like an L that's kind of been pushed over. Okay, so it's an L for less than. All right, so I want everything less than 3, which means this point works, and this point works, and this point works, this point works. All of these points work. And in fact, the point this point works. So what I do is I use an open point right there to say I'm going to scream all the way up to 3, but not touch the 3. So you're going to approach the value of 3, but not equal 3. Okay, you're going to get right in its face, but you're not going to equal 3. Well, math people are lazy, which means I don't want to do this my entire life. So what I do is I get a little bit sloppy, and I say I am interested in 3. I'm interested in everything over here, and when I get to here, it's an open circle. Okay, notice there's an arrow on the end here that says that it keeps going. So this is what it means. There's an infinite number of points. You're going to approach 3, get infinitely close to 3, but not touch it. So that's what the open circle is for. Now, I want to convert this to interval notation. So interval notation, we're going to read from left to right. Okay? we're going to read from left to right, which means both of these are the same picture. And if I start over here to the left, remember this continues on to the left, and that continues on to the left because it's the same graph, okay? But I'm in my answer right now. I'm in my answer, in my answer, in my answer, in my answer. Oop, not there anymore. Okay, and then there's nothing over here that works because nothing over here is less than 3. 5 is not less than 3. 10 is not less than 3. A bajillion is not less than 3. So I'm going to say where my answer starts. Well, my answer starts somewhere to the left, which is where negative infinity is. Okay, and I'm going to use a parenthesis for that answer. So up here, when we used open circles, now we're going to use parentheses. Okay, and it just depends on which way we're looking. Okay, so I'm going to explain, we're going to give lots of examples. So my answer starts somewhere in negative infinity. Well, where does my answer end? I've got all of these up here, but I cannot write this 2.99999 number. So what I do is I say it comes up to 3, and then this soft bracket says don't touch it. So approach, but do not touch the 3. So this means the exact same thing as this does. Okay, this is interval notation. This is inequality notation. So let's try another one. We have -4. Let's just do x is greater than or equal to -4. So on a number line, what number am I interested in? I'm interested in -4. X is bigger than that. So bigger. X is all of the points to the right, because that's everything that's bigger than -4. And then can my answer be -4? Yes, because math people are lazy. What that really says is x is greater than or it is equal to -4. So yeah, is -4 equal to -4? Yes, it is. So I'm allowed to use that -4. So I've used a number line to show you inequality notation. Well, now we're going to translate that into inequality notation. So reading from left to right, where does my answer begin? My answer begins somewhere in no, it doesn't. I have no answer over here. Where does my answer start? Well, my answer starts at -4. And now we're going to introduce a new bracket. Can it be -4? Yes, it can, because -4 equals -4. So -4 is fair game. That's why we had a filled in circle, because I'm including that point. So I'm going to use a hard bracket for -4. Okay, where does my answer continue off to? Well, it keeps going into positive infinity. So positive infinity will always get a soft bracket. Now pause for a second. Where did this come from? Let's go back over here. And if I am using the equal to's, okay, I'm going to use hard brackets. And because I'm a lazy math person, I'm not going to call these parentheses. I'm going to call them soft brackets. These are hard brackets. Well, now let's look at the infinities. Infinities are the negative infinity and the positive infinity. Those are concepts. They are not numbers. You can only equal a number or a formula. Okay, I can't equal a concept. So if you're dealing with negative infinity or positive infinity, you will never use a hard bracket, because if you use a hard bracket, you're saying, oh, it equals infinity. Okay, and infinity is a concept. It's not a number. So let's go back through this thing. Now that I know, now if you're looking for little ways to remember this stuff, you've got a horizontal bar for the equal to, right? You've got a horizontal bar for the equals to, okay? You also have horizontal bars here, okay? So that gives you a little visual clue that you better be including hard brackets somewhere in your answer. All right, so let's try another one. I have x is less than or equal to 7. So what number am I interested in? I'm interested in 7. And what I'm going to do this time is I'm going to go ahead and instead of using filled in circles or open circles, I'm going to use the bracket. Okay, so I'm interested in 7. X is smaller than 7, so I'm interested in everything over here. And then the way I work the bracket is that its little arms will hug the answer. In other words, which bracket do I use? Do I use this bracket or do I use this bracket? Well, if these are his arms, and if these are his arms, I want the arms to hug the answer. Okay, so now tell me, this is just a representation. Tell me in interval notation, where does my answer begin? I'm already in it. My answer begins in negative infinity, who always gets a soft bracket. Okay, comma. Where does my answer end? My answer ends at 7, and not only do I approach 7, but I can equal 7. So he gets a hard bracket. Okay. Let's do another one. What if I have something like 3 is less than x is less than or equal to 9? Okay. Well, now let's read this, and don't just dive in. Listen to what you're saying. This says that 3 is less than x. 3 is smaller than my answer. 3 is smaller than my answer. So if I put this on a number line, here's my 3. And let me grab a pencil. Pencil. Hang on. Good heavens. My children stole my pencil. Got it. Okay. So what I can do is say 3 is the smallest that my answer. 3 is smaller than my answer. So that must mean that my answer is bigger than 3. Okay. Now look at this part. X is smaller than 9. X is less than 9. So here's 9. So shade what's less than 9. So now I'm going to shade this way, and I'm going to say everything that's less than 9. So the overlap is your answer. This part is not overlapped. It only belongs to this portion. This part's not overlapped. It only belongs to this portion. So what's the overlap? The overlap is the stuff between 3 and 9. So what kind of a bracket does the 3 get? Okay, does 3 equal x? No, it does not. So the arms hug the answer. And then what kind of a bracket does the 9 get? He can equal 9, so the arms hug the answer. So my answer for this one in interval notation begins at 3 and goes over to 9, negative, what? Positive 9. I don't even know where that just came from. Goes over to 9 inclusive. All right, so I'm going to do some more examples in the next video and just talk you through some more practice.